Hello everyone. Today I'm here with you all with the last chapter of class ninth maths curriculum, that is probability. We are already having videos on the first 14 chapters of class ninth maths curriculum. So with this video we'll be finishing the syllabus of class ninth maths. Along with that we are even having videos on all the 14 chapters of class 10th maths curriculum even along with the practice questions. So if you have not yet subscribed my channel, please do subscribe it. So let's start with the chapter that is your probability. So what probability is? In our day-to-day life, we come across so many sentences like it is most likely it will be raining today. That there are the chances that India will win today. Most likely he or she will be scoring good marks in this examination. So whenever we are using the term like most likely, probably, so all these sentences shows your uncertainty. When we are expressing this uncertainty, quantitatively it is your probability. So what probability is? Whensoever the chance of happening of any of the event when expressed quantitatively, it is called your probability. When we are expressing the uncertainty of any of the event or your happening chances of happening of any of the event quantitatively, we say it to be your probability. So how we will be expressing it quantitatively? For that we will be conducting experiments. So what experiment is? Experiment is an operation that can produce some well-defined results. The results of the experiment is known as your outcome. So let's take an example like we are doing the experiment of tossing a coin. We are doing an experiment of throwing a dice. So in these experiments, suppose we are taking for your tossing a coin. So your outcomes could be your either head will come or your tail will come. So coming of head and coming of tail is your outcome. When we are throwing a dice, either one will come on the dice, on the top of the dice, either two will come on the top of the dice, or three, or four, or five, or six. So all these 1, 2, 3, 4, 5, 6 that will come on the top of the dice, that are your outcomes. So these are the experiments which we will be conducting for converting your chances of happening of any of the event your quantitatively. Like we want to check that what is the fraction of getting a head when we are tossing. So for that we will be conducting the experiments. So multiple times we will be throwing the coin. We will be tossing the coin. So this will be known as your experiment. Now what random experiment is? There are so many types of experiments are there, but in this chapter we'll be doing the experiments that will be your random experiment only. Random experiments are even known as your probabilistic experiments. So experiment is random if although it is repeated in same manner every time can result in different outcomes. So we can repeat the same experiment will be conducting so many multiple times, but always it is not compulsory that we will be getting the same result, same outcome we will be getting. The outcome could be different. Like when we will be tossing a coin, it is not compulsory that always head will come or always your tail will come. Sometimes head will come, sometimes tail will come. So it is not certain that the same result will come always. So all these type of experiments are your random experiment or it is your probabilistic experiment. Now what trial is? A trial is an action that results in one or several outcomes. Like when we are conducting the experiment, suppose we are conducting it 100 times or 1000 times to come to any of the conclusion. So every time we are doing the experiment, every single time, that means suppose 100 times we have tossed a coin. So every single time we are tossing a coin is your trial. That will be your trial, and in that trial either your head will come or your tail will come. So a trial is an action that results in one or several outcomes. Now comes your event. An event is a collection of some outcomes of the experiment. Like when we are conducting any of the experiment, so when we are collecting some of the outcomes, it is your event. Like if I am saying that I am throwing a dice, so if I'll be saying that what is the probability, what is the chance that the number at the top will be your even number. So if 2 will come or 4 will come or 6 will come on the top of the dice, then all these are your favorable conditions. All these are the conditions which will suit the event. So collection of all these outcomes, that means 2, 4 and 6, that will be the event. Event is a collection of outcomes of the experiment. If I am saying that that on the top if your 1 will come, then what is the probability and what is the chances of happening of this event? So event will be your coming of 1 at the top of the dice will be your event. If I am saying that coming of the prime number is the event, then if your 2 will come, or 3 will come, or 5 will come on the top of the dice, then it will be the event. Event will be coming of your 2, 3 or 5 on the top of the dice. So it is your event. Event is a collection of some outcomes of the experiment. Now, when we know that what experiment is, what random experiment is, what is trial and what is event, so how from all this we can find the experimental or empirical probability of any of the event E happening. So formula for finding the probability of an event E is, that is denoted by your PE, that will give you number of trials in which the event happened. Whatsoever the event we have taken, the number of times in which the event has happened divided by total number of trials will give you probability or the empirical probability of an event E happening. Suppose I am saying that I have tossed a coin. Now I am taking event as your coming of your head is the event. Suppose I am saying that 100 times I have tossed it, 100 times I have tossed a coin, and out of this 100, your 47 times head has come. Head has come your 47 times, and event we have taken is your coming of head is the event. Coming of head is the event. In that case, probability of the event, if I am assuming that this event is your E, in that case probability PE will be number of trials in which the event has happened. Event has happened for your 47 times, and the total number of trials was your 100. So 47 divided by 100 will be the probability of the event. Event was your coming of your head. Now, if I am saying of tail, what will be the probability of getting a tail? If the event is for getting a tail is the event, in that case, if 47 times head has come, obviously your 53 times your tail has come. So probability of getting a tail, if it's probably if event is denoted by suppose F, in that case probability of F will be number of times when your event has happened, that is your 53 times, divided by total number of trials, that is your 100. So the probability of the event will be given by your 53 over 100. So this is how, when we know how many number of times we have made the trials, how many times our event has happened, then we can find the probability of any of the event happening by the formula number of trials in which the event has happened divided by the total number of trials. Now let's understand how to find the probability using some experiments. Suppose we are conducting your first experiment in which we are tossing a coin. 1000 times we have tossed the coin, and out of these 1000 times head we got by your 456 times we got head, and 544 times we got tail. Because when we'll be tossing any of the coin, either head will come or your tail will come. That simply means if head has come for your 456 times, your tail will be your 1000 minus 456, that will be 544 times your tails will come. Now, if we will be finding the probability of the event if we are taking off your head, coming of head is the event, then the probability of the event E will be, if this is your event E we have taken as coming of your head. So it will be your 456 number of times your event has happened divided by total number of trials, that will be your 1000. So we can write it as your 0.456 also. This will be the probability of the event, where event is your coming of your head. Now if coming of the tail is the event your F, suppose this is the event F, so probability for your event F will be number of times your event has happened, that is your 544 times. 544 divided by your 1000, that is your number of trials. So it will be your 0.544. So if we are going to add these two, probability of your event E plus probability of your event F, it will be your 0.456 plus 0.544. That will be 6 plus 4 will be 10, carry over 1, 5, 4, 9 and 1, 10, carry over 1, 5, 4, 9 and 10, carry over 1. So it will be your 1. Probability of getting head and probability of getting your tail, if we are going to add these two, it will be your 1. So when we will be tossing, either your head will come or your tail will come. So if we will be considering all the possible outcomes of any of the event, of any of the experiment. If we have conducted the experiment of tossing a coin, and the possible outcomes could be your either coming off head or coming off tail. So if we have considered all the possible outcomes, then the probability of these events will be on 1. Similarly, if we'll be conducting any another experiment of your throwing a dice, if we have thrown a dice your 1000 times, and the one has come for your 170 times, one has come on the top of the dice, 159 times your 2 has come on the dice, 150 times your 3 has come on the dice, 156 times your 4 has come on the dice, 170 times your 5 has come on the dice, and 195 times your 6 has come on the dice. Now, if this is the case, and we are saying that probability of coming 1 on the top of the head or top of the your dice is your event is your this is your event, say F. Suppose coming of 3 is the event G. If coming of your 4 on the top of the dice, say it is your H, this is your I, and this is your J. These are the events. If on the top of the dice 1 is coming, it is your event E. If it is 2 is coming, then it is your event F. If 3 is coming on the top of the dice, suppose it is your event G. Similarly, this is your event H, this is your event I, and this is your event J. So probability for the event E is, probability for the event E will be number of times your event E has happened, that is your 170 times, and total number of trials is your 1000. If we will be adding all this, total number of trials is your 1000. So probability of event E will be your 170 divided by 1000, that is your 0.170. It is the probability for the event E. Now, if we will be taking probability for the event F, it will be 159 divided by 1000, because 159 times your event F has happened. F is your coming of 2 on the top of the dice was your event F, and it has happened 159 times. So probability for the event F will be number of times event F has happened divided by total number of trials, that will be your 1000. So it will be 0.159. Similarly, probability for your event G will be 150 times your event G has happened divided by total number of trials was your 1000. So it will be 0.150. Probability for the event H, that is coming of your 4 on the top of the dice, is your event H. So probability for that will be 156 times event H has happened divided by total number of trials was your 1000. So it will be 0.156. Similarly, probability for event I will be 170 divided by 1000, that is your 0.170, and probability for the event J will be 195 divided by 1000, that will be 0.195. So when we will be throwing a dice, either 1 will come, or 2 will come, or 3 will come, or 4 will come, or 5 will come, or 6 will come. There is no other possibility that your 0 could come, or your 7 could come, or any other number could come. So what all the possible outcomes were there, we have taken all the possible outcomes. In such type of cases, when we have considered all the possible outcomes, and we will be taking all as the event, coming of 1 we have taken as the event, coming of 2 we have taken as the event, we have taken all these events. If we will be adding all the probabilities for all these events, see PE, probability for the event E, probability for the event F, for your G, for your H, for your I, and for your G. If we will be adding all this, this will be 0.170, 0.159, 0.150, 0.156, 0.170, 0.195. If we will be adding it, so 5, 11, 11 and 20, that is 0, carry over 2, 9 to 11, 18, 18, 23, 23, 28, 28, 33, 44, carry over, 4, 1, 5, 6, 7, 8, 9, 10. That means the sum of all the events, probability for all the events will be your 1. So whensoever we have taken all the possible outcomes and we have taken the all as a event even, and we have taken the probability for all the events, then always and always their sum will be equivalent to your 1. Here in this case even we have seen that the probability was in either your head will come when we will be tossing a coin, or your tail will come. No other possibility is there. So we have taken all the possible outcomes. Then probability for event when your head will come, probability for the event when your tail will come. If we will be taking both of them, the sum will be 1. Similarly over here even we have seen either 1 will come, 2 will come, 3, 4, 5, 6 will come on the dice if we will be throwing a dice. So if we will be taking all these as the event and we will be finding the probability for all these events, their sum will even be your 1. We can see over here probability for every event will lie between your 0 and 1. The probability for any event, whatsoever the event we have taken, whether it is of coming of your head or tail, or coming of 1, 2, 3, 4, whatsoever. So probability always lies between your 0 and 1. One of the conclusion what we can take is that the sum of the probabilities in these type of cases, it will always be 1. Another we can take it as that whatsoever the event we have taken, the probability of the event will lie between your 0 and 1. It is not going to exceed 1 and it will not be less than 0 even, right? Why it won't exceed your 1? Because the number of trials we are taking as a denominator, and number of times your event has happened we have taken as a numerator. So obviously number of trials will be more than the number of events, number of trials in which your event has happened. So it is never ever going to exceed your 1 even, and it will not be your negative even. It will lie between, probability for any of the event will lie between your 0 and 1. So we can conclude that sum of all these events, when we will be finding all the probabilities for all these events, will be your 1, and probability will always lie between your 0 and 1 only. It will not exceed 1. It won't be less than 0 also. Now, if we are going to conduct your experiment of, suppose you're tossing a coin multiple times means the more we will increase the number of trials, the more we will increase the number of trials, the value of probability of getting a head and the probability of getting a your tail, it will be somewhere around your 0.5. It is the conclusion. How we will be getting it, we will be learning this in your class 10th, but here we'll be learning that the more our number of trials will be, as we are going to increase the number of trials, the probability of getting the head and the probability of getting a tail will be somewhere near your 0.5, or we can say 1/2. Similarly, if we are going to increase the number of trials over here in throwing a dice, in that case probability of getting 1, probability of getting 2, or probability of getting 3 or 4 or 5 or 6, the values will be somewhere around 1/6. The probability of getting all these values, probability of getting 1, probability of getting 2 or 3, or probability of getting 4, or probability of getting 5, or probability of getting 6, all these value will be somewhere near 1/6. This will be the case when we will increase the number of trials. The more the number of trials we will increase, the value will approach to your 1/6 for all these cases. For all these probabilities will be somewhere near 1/6. We can convert it into decimal and the value will be somewhere near to that only. So these are your experiments we have conducted. What we have done is, experiment was of your tossing a coin. Now 1000 times we have tossed, that means 1000 were your trials. If we are taking the case of your head, that means we are taking that how many times your head has come, that this is the event in that case. If we are taking how many times your number of tail has come, if we are finding the probability for that, then it will be the event for that. And if we will be getting the probability for these events, the formula will be number of times your event has happened divided by total number of trials. So this is how we can get the probability for any of the event. Now let's understand some of the questions from your exercise 15.1. First of all, we are seeing the question number 1. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls. She played 30 balls. Out of these 30 balls, she hit a boundary on 6 times. Find the probability that she did not hit a boundary. So over here, event is did not hit a boundary is the event. Event is your when she did not hit a boundary is the event. So if on 6 times she hit the boundary, so on how many balls? How many balls were there? How many balls were there on which she did not hit boundary? Did not hit boundary. If total 30 balls were there, on in 30 balls she hit the boundary on 6 balls, so 30 minus 6, that is 24 balls were there on which she did not hit the boundary. Now event we are taking as did not hit the boundary is the event. The number of balls on which she did not hit the boundary is the event, and suppose your event is E. So probability for the event E is number of balls on which she did not hit the boundary, because event is your did not hit the boundary. So number of balls on which she did not hit the boundary, that will be 24, will be the numerator, divided by total number of trials. Over here total number of balls she played was your 30, so divided by 30 will be the probability of not hitting the boundary. So it will be 6 4 is 24, 6 5 is 30. So probability will be your 4 upon 5 will be the probability. Now let's see the second question. 1500 families with 2 children were selected randomly and the following data were recorded. Number of girls in a family was 2, 1 or 0, and number of families in which 2 girls were there, there were 475 families were there, in which 1 girl is there, in such families were 814, and the families in which there were no girl child were your 211. Total 1500 families were randomly selected. So number of trials is your 1500 is the number of trials. Now the compute the probability of a family chosen at random having 2 girls. So over here event is your having 2 girls is the event. The first part we are talking about the 2 girls. Now how many families were there in which there were 2 girls? There were 475 families were there, and total number of trials was your 1500. So total trial were 1500, and number of families having 2 girl child is your 475. So probability of selecting a family which is having 2 girls will be, suppose this is your event E, then PE will be 475 were the number of families in which there were 2 girl childs were there, and total number of families selected trial experimented is your 1500. So divided by 1500 will be the probability of having your 2 girl child, selecting a family which will be having your 2 girl child. Now if we will be cutting it, so it can be cut by your 25 even or 5 even. So first I am cutting it by 5. 5 9 is 45, 5 5 is 25, 5 3s are 15. Then again they are divisible by 5 here. 5 1 is 5, 5 9 is 45, 5 6 is 30. So 19 upon 60 will be the probability of getting selected a family which will be having your 2 girl childs. Now the second part is your having 1 girl child. What is the probability that the family will be selected will be having your 1 girl child? So from the table we can see that there were 814 families. 814 families were there who were having your 1 girl child out of 1500 families. So suppose the event is your F. Event of selecting a family which will be having only 1 girl child is your event is your F. So probability of F will be number of families, your 814 were the number of families which were having your 1 girl child, and total number of families which we have experimented, which we have selected, which we have your selected randomly were your 1500. So 814 divided by your 1500 will be the probability that the family selected will be having 1 girl child. So both are divisible by 2. 2 4 is 8 and 2 7 is 14 divided by 2 7 is 14, 407 over 750 will be the probability that the family will be selected will be having 1 girl child. Now the third part is that the family selected will be having no girl child. Now there are 211 families which were having no girl child. So suppose the event is your say G. So probability of G, that will be your 211 girls were there, families were there which were having no girl child. So this will be the numerator, and total number of families were your 1500. So 211 over 1500 will be the probability that the family selected will be having no girl child. So this is how we can solve the question. Now let's see question number 4. Question number 4. 3 coins are tossed simultaneously 200 times. So number of trials is your 200 times with the following frequencies of different outcomes. 3 heads came 23 times, 2 heads came 72 times, 1 head came 77 times, and no head 28 times. So if the 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. So over here from the table we can see 2 heads came your 72 times 2 head has come. Now if the event is your getting 2 heads is the event, we are assuming that the event is your getting of 2 heads is the event, then probability of the event will be number of times your 2 heads has come, that is your 72 times 2 head has come. So it will be 72 divided by total number of trials is your 200. Total number of trials is your 200. So we will be dividing it by 200. Now both are divisible. So first I am dividing it by 4. 4 5 is 20. 4 1 is 4. 4 8 32. Again they are divisible. So it will be 9 upon 25. So probability of getting 2 heads will be on 9 upon 25. Now question number 5. An organization selected 2,400 families. So number of trials is your 2,400. Because 2,400 families were selected at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. Over here a table is given, monthly income, vehicle per family, in which in monthly income it is less than 7,000, 7,000 to 10,000, 10,000 to 13,000, 13,000 to 16,000, and 60,000, 16,000 or more. And vehicles per family is 0, 1, 2 and above 2. Now suppose a family is chosen, find the probability that the family chosen is earning rupees 10,000 to 13,000 per month. So we will be selecting your second row, because not second, third, because earning is your 10,000 to 13,000. So 10,000 to 30 in the monthly income we will be checking your 10,000 to 13,000, that is your row number 3 will be taking per month and owing exactly 2 vehicles. So under the 2 vehicles category if we will be going, it is 29 were the families who were having 2 vehicles, exactly 2 vehicles, and which comes under the category of which were earning, whose monthly income was your 10,000 to 13,000. So from here we will be going first 10,000 to 13,000, and from here the number of vehicles 2. When we will be coming to and your 10,000 to 13,000, if we will be just taking it, the number is your 29. There are 29 families who are earning in between 10,000 to 13,000 or who are having your 2 vehicles per family. So there are 29 such families, and total number of trials were your 2,400 families were taken. So question number 5, first part, it will be total number of families, your event, if we are assuming to be E. If event is E, then probability for the event will be, there are such 29 such families and out of 2,400 families. So probability will be your 29 over 2,400. Now the second part is earning is rupees 16,000 or more. So last row will be considering 16,000 or more per month and owing exactly 1 vehicle. So under the category of 1 vehicle, and your last 16,000 or more, it is your 579 families are there who are having exactly one vehicle and who are earning 16,000 and above. And if the event is your F, then your total number of families which is for having this as your event, that is your 579, divided by total number of trials were your 2400. So this will be the probability that the earning of the family will be 16,000 and more, and they will be having exactly one vehicle. Now the third part is earning less than rupees 7,000. Earning less than 7,000, that means first row will be considering per month and does not own any vehicle. Then the first, that is zero vehicle, we will be considering the zero vehicle and less than 7,000. So when we'll be mixing these two lines, then it will be your total number of families is your 10. There are 10 such families, and suppose your event is your G, event of selecting a family which is earning less than 7,000 per month and owing no vehicle. If this is the event G, then the probability of the event G will be your total number of such families are your 10, and total number of trials were your 2400. So we can say it will be, probability will be 1 upon 240 will be the probability. Then fourth part, earning rupees 13,000 to 16,000 per month, that is second last row will be considering monthly income 13,000 to 16,000 per month and owing more than two vehicles, and the last column above two vehicles, and your 13,000 to 16,000 monthly income. The number of families were your 25, we can see over here, it will be your 25. So if the event is your I, event of selecting a family who is earning rupees 13,000 to 16,000 per month and owing more than two vehicles, if this is the event I, then the probability of this event will be, there are 25 such families, so 25 are the number of families out of your 2,400 families. So if we are going to cut it, so it will be your 25, 1 is 25 and 25 96 it will be. So it will be 1 upon 96 will be the probability. Now the fifth part, owing not more than one vehicle. Now it is not given that what is the monthly income, it is not given. Simply the question is what is the probability that the family selected will be having no vehicle, not more than one vehicle. That means zero vehicle will go and your one vehicle will even go. So whatsoever the number of families are there in this column in which there is zero vehicle and the number of families which is having your one vehicle, we will be adding all these families because we have to select any of the family which is not owing not more than one vehicle, not more than, that means zero vehicle will go and one vehicle will also go. So we will be adding all the families which will be having either zero vehicle or which will be having either your one vehicle. So we will be adding all these families. So your first of all we will be finding the number of families which are coming under this category. So it will be, first we are taking from the families which is having zero vehicles. So it will be 10 plus 1 plus 2 plus 1. These are the families which is having zero vehicle. We will be considering all the monthly incomes because monthly income is not mentioned to us. Then we will be taking your families which is having one vehicle. So 160 plus 305 plus 535 plus your 469 plus 579. So if we will add 10, 11, 12, 13, 14. 14 is this, and addition of all this will be your 2048. Addition of this column, this is your 2048. So summation will come your 2062 will be the families which will be having either your zero vehicle or they are having your one vehicle. So these are the number of families. Now if your event is say J, if J is the event of selecting any of the family which is not having more than one vehicle, then probability of this event J will be 2062 and total number of families were your 2400. If we are going to divide it by 2, 2 1 is 2, then 2 3s are 6, 2 1 2 1 it will be 1031 divided by 1200 will be the probability of selecting a family which is not having more than one vehicle. So this is how we can solve the questions. Now let's see question number 7. To know the opinion of the students about the subject statistics, a survey of 200 students was conducted. That means number of trials is 200. The data is recorded in the following table. Opinion like the students who like the statistics is your number of student is 135, and the students who did not like or dislike your subject is your 65 other students. Now to find the probability that a student chosen at random like statistics. Now if the probability of the event we are taking the students who are liking the subject, liking the statistics is your event E. So probability of selecting a student who like your statistics, PE, will be, in the numerator we'll be taking the number of students who like your subject statistics, that is your 135, and total number of students who were trialed were your 200. So 200 will be the denominator. This is your number of trials. Now if we will be dividing it, 5 4 is 20, 5 2s are 10, 5 7 is 35. 27 upon 40 will be the probability of selecting a student who likes statistics. Now the second part is who does not like statistics. Suppose the event is your F. Of does not like statistics is your event F. In that case, now how many students were there who did not like your statistics? It is your 65. So probability of the event will be 65 divided by your 200. So 5 1 is 5, 5 3s are 15, 13 over 40 will be the probability. Now let's take one more question, that is question number 11. 11 bags of wheat flour, each marked 5 kilogram, actually contained the following weights of flour in kilogram. Question number 11 it is. Some weights are given of how many bags are there. 1 2 3 4 5 6 7 8 9 10 11 bags were there. It's written even 11 bags of wheat flour were there. Find the probability that any of these bags chosen at random contains more than 5 kilogram of flour. So the event is that the bag should have more than 5 kilogram of your flour. This is the event, and we are assuming that the event is your E. Now how many bags are there who are having more than 5 kgs? So 5.05 is having more than 5, right? 5.08 is having more than 5. Then your 5.03 is having more than 5. We won't be considering 5.00 because it is your 5 kgs and the event is your more than 5 kgs. So we will not be considering 5 kgs. Then it is your 5.06 will be more than 5, 5.08, 5.04, 5.07, and again 5 is there, we won't be considering that even. Total number of bags were your 11. So how many bags were there whose weight is your more than 5? So 1 2 3 4 5 6 7. There were total of 7 bags were there whose weight was above 5 kgs. Suppose the event is your E, then it will be number of bags which are having more than 5 kgs is your 7. Total number of bags were your 11. So probability will be your 7 upon 11. So this is how we will be solving the questions. We will be taking the event, and probability of the event we can find by number of trials in which your event has happened divided by total number of trials which were conducted. So hope it is clear to you what probability is, what event is, what trial is, and how we can find the probability of these type of questions. This is all from this chapter. Hope it is clear to you. Now we have finished the class 9 syllabus. Soon we'll be meeting with more videos on other topics of your class, of your maths. Thank you.